whatever the doubts that you have. Okay, whatever the doubts that you have, I try to clear out all the doubts. So in this session, what we are going to do here is, okay, in this session, what I'm going to do here is, we are going with a concept of understanding what is meant by container, what is meant by Docker, and how we are going to work around with the Docker. Okay. So now, in the previous session itself, we discussed about the Docker. What is Docker? Docker is a packaging tool where it is going to pack the application and its dependencies into a package form called as container. That is what we have discussed. So it will pack Docker. It will pack the application and its dependencies into container. This is what we discussed. So if you check out in the previous class what we have discussed. So what is this container is all about? So what is this container? So when we have to discuss about the container, okay. So but before we go into the container concept, from where this container concept was introduced, okay. So where is this actual container concept got introduced, and how we are going to work with the containers. So if you see in a Linux operating system, let me do one thing. I will deploy in Linux server or else Linux instance in my AWS account. Okay. So I have an AWS account. In this AWS account, I am going to deploy an EC2 instance. So in tomorrow's session, I will discuss about how to create an EC2 instance and how to access that EC2 instance. Everything we will be discussing about the EC2 instances in the next session. But as of now, let us see what and how we can create this container. Okay. Right. So now if you see here, I will try to create an EC2 instance, which is T2 micro 1. That's more than enough for me. For example, I will make it as Docker server. I'll go with the Ubuntu operating system. What is all these AMIs and everything we will discuss in the next session. Don't worry about how we are creating this EC2 instances. Those who have knowledge on EC2 instances, they can create it. If you don't have any knowledge on EC2 instances, don't worry about that. Anyways, we are going to discuss about this concept in the next session. Okay. I will launch the instance. So does anybody is having any knowledge on Linux operating system? Not only Linux, Windows or also any operating system. Does anybody have any knowledge on this? Come on guys, speak out. Yes, I'm talking to each and every candidate over here. Do you have knowledge on this Linux operating system, Windows operating system, any operating system? It is not like you need to have a very good understanding. Okay. So now the point is, whenever you open an application, what happens in the background? Can you tell me about that? It's just a simple question here. If you are running any application, just for example, in Windows, I am running this putty. Okay, when I run this application, what happens in the background? So in the background, what is going to happen if you see the task manager? Okay, if you can see the task manager, the applications whatever running will be displayed over here. The processes that are running in your operating system, how much amount of memory that those are going to consume, that is going to show you here. Here you can see background process which are running and how much amount of CPU and memory that this is going to consume. So which means that in your entire whatever I am calling in your entire operating system, I have 99 background processes that are running and supporting my operating system to run. And not only that, in the front end, I am having some 5 applications that are running, that is Google Chrome, Notepad, SSH, Task Manager, and Zoom Meeting. These are the applications that are running in the foreground, or that are the applications that I can see. Applications are nothing but the multiple processes. Okay. So which means that not only in your Windows, let me show you in your Linux operating system also. If you give ps-pf, here you can say these many number of processes that are working in your Linux operating system. In your server also, these many number of processes that are working. So which means that, so what is this process is all about? A process means the whatever the applications that are running, to help that application, we need to run certain background processes. For example, now we are watching an YouTube video. If you are watching a YouTube video, multiple processes should be running. Video related processes should be running. Audio process should be running, and for streaming in networking processes that should be running. So like that, most number of processes will be running to run a simple application. In the same manner, what is this container? And before we dive into what is meant by a container, so Linux, when we come to the Linux operating system in the good olden days, the IT experts find out there are processes that are running, and one process will not interacting with the another process. They are in an isolated environment. Try to understand this point. For example, if I open Google Chrome over here, okay, in the Google Chrome, if I open another tab, so in the another tab, I can open certain banking application. This is a new tab, okay, where this particular, let me tell you, this is like a process. This new tab will not have any effect on the another tab, which means that even though inside the application, even though all the tabs that are inside the application are, are on a single application, but one particular tab doesn't have to do anything with the another tab, which means that one process doesn't have to do anything with the another tab, which means that they are in the isolated environment. So in the same manner, for any application, if you take any another application, okay, if you take any another application, the process that is running with inside an application will have an isolated environment with the another process that is running in the same application. That is what they have find it out. So if you see here, PS, if when I give the command PS, so here you can see there are multiple processes that are running. So one process is having an isolated environment over the another process. Now, what is this called as? Actually, they find out they came with a new theory called as C groups and namespaces. Let me show you with that. I'm not going to go with very in-deep technicalities, but if you have anything to ask me, you can ask me now. Any questions?
Hello, sir.
Yes.
Is this demo session going on for Docker and Kubernetes?
Yeah, it's a demo session itself.
Okay. Fine. Just now
Why,
joined.
why you have that particular question came into your mind?
So I joined little late, and I
Mhm.
see, the pace with which you are going on. I thought some other session is,
No.
some.
So I'm talking about the C groups in the Docker. I am talking about the containers itself. First of all, you need to understand what is a container. Then only you can work with the containers, right?
Okay.
Yeah. So now when you see, there is a concept called as C groups introduced and namespaces introduced. So there is one more concept that got introduced over here is namespaces. 1 second, guys. So as I have said you, namespaces are the core feature of Linux kernel that Docker leverages to provide the isolation of the containers. So what is this concept of kernel? Okay, so everyone will have a doubt with that. First of all, let us discuss very basic concept, and then we'll combine all the points into a single line. Okay, so there are multiple points that we have to discuss. So for example, if user has to communicate with the computer, how user will be able to communicate with the computer? If he has to run an application, okay, there is a user. This user is accessing a computer, just very basic thing. Okay, so how this user will interact with the computer interaction in the sense hardware. Why? Because he has to open an application. So to open the application, hardware has to function, processing unit should be there, RAM should be running. So how this user will be able to interact with that computer? Yes, user interface. Exactly. So with the help of an operating system. So this user will be interacting with the operating system. So the operating system itself will help the user to communicate with the computer. Do you understand my question here? The user who is trying to access the hardware, is operating system alone will be helpful for him. So what is this OS? Everyone will say that OS is an interface between the user and the hardware. But in general, when you go backwards, okay, in 1971, the Unix operating system in 1970s, Unix operating system was developed in the Bell Labs. Okay, Bell Labs, with the help of two scientists with a majorly two scientists are involved into that to develop that operating system. His name is Ken Thompson, and who is the who is the father of C language developers, Ken Thompson and Dennis Ritchie. Okay, so these two guys has involved into developing an first Unix operating system. So they developed the unique operating system, but the main point here is they have introduced a premium concept. Premium in the sense you have to purchase the operating system. Okay, so there is this person called as Richard Stallman. Okay, there is this person called as Richard Stallman. He opposed that particular thing. So already we are purchasing hardware. Already we are purchasing the laptop and its peripherals and everything. I mean, desktop and its peripherals and everything. Why again we need to go with the purchasing of the operating system? Why can't we get the operating system in the free version or also open source? Why can't I do that? So then he started working on the operating system, and his name is Richard Stallman. Remember this? And he introduced a new operating system called as GNU. You might be thinking this is not irrelevant. This is irrelevant, but let us connect all the dots in a single point over here. So he has introduced a concept called as operating system called as GNU. What is GNU over here? It doesn't have any full form. Okay, G not Unix, GNU not Unix. That's it. So then what he has done, he has developed the entire applications and the entire everything, and he is running very pretty good, and everything is fine now. He doesn't have any problem, but he failed to develop a particular thing called as kernel. Okay, he failed to develop the kernel over there. So kernel is like a backbone for your entire operating system. Whatever the management, process management, memory management, network management, disk management, everything will be maintained by the kernel itself. Kernel is like a compiler. It is going to convert the user understandable language into the binary language, or else I can call it as a computer language. Okay, so kernel is the main application or else main entity that should be there inside an operating system. Without the kernel, the operating system will not be able to work. So this guy, Richard Stallman, is failed to develop that kernel. And in 1990s, there is a person called as Linus Torvalds who has developed the operating system, or else who has developed the Linux kernel. Linux in the beginning, it's a kernel, and he has integrated this Linux with the GNU, forming GNU Linux as the first flavor of your entire Linux operating system. Try to cope up with me what I'm trying to explain here. There is a person called as Richard Stallman who has developed an operating system called as GNU, but he failed to develop the kernel, and due to which the operating system was not published in 1990. Linus Torvalds, you know about him. He has introduced the Linux kernel into the market, so that these two guys, the Richard Stallman and the Linus Torvalds, integrated and collaborated, they have developed a new operating system called as GNU Linux, which is a first freeware and open source operating system available in the market. With the help of that, nowadays lots of distributions, lots of flavors of Linux has been introduced. Red Hat, SUSE, Ubuntu, a Debian related one, Kali Linux, and then you can go with CentOS. Like so many number of Linux operating system came into the market. Now, which is very important, kernel is very important. Now, what is this kernel? Kernel is a management entity. It's a management application. It can do the process management, memory management, how many applications are running, which application I have to code, how much amount of space, how much amount of processor, how much amount of RAM. These are the things that will be decided by your kernel. So without kernel, the management, the process management, memory management will not be done. So this is what I am talking over here. Whenever we are discussing about the namespaces, namespaces are the core features of Linux kernel that Docker leverages to provide the isolation for containers. So here we are discussing into the Docker, so that's why it is introduced over here. But in general, namespaces in the Linux operating system will offer the Linux kernel to understand each and to segregate each and every process. For example, I am running a Java application in my server. In my server, I am running a Java application. Okay. And in the same server, I am running a Python application, Python app. Now, who will segregate these two applications? So Java application requires more amount of memory. Python application requires this much amount of memory, and Java application requires how much amount of processing, and Python application requires how much amount of processing. How we are going to segregate that? Are we going to segregate, or else automatically server is going to segregate the resources between these two applications? What is going to happen over here? Who is going to segregate? Who is going to differentiate these two applications? There should be someone who has to differentiate, right? So without differentiating, the Java application will be running and there will be an interruption of Python application in between, so that there will be problematic situation for them. So they should be isolated. So one application should be isolated with the another application. So who is going to do this isolation kind of thing? Namespaces will do the segregation between these two applications. So this is a Java related application. This is a Python related application, depending on the command which we are providing. So now what is happening? Now namespaces will be dividing the processes. Namespaces will be dividing the processes in the back end. Who is going to manage all the processes, all the applications? Kernel will be managing all the applications. How much amount of process I have to give, processor I have to give, how much amount of memory I have to provide. These can be done by the kernel. So now that is what it is describing over here. Okay, what are the purpose of the namespaces? Namespaces isolate the critical aspects of systems such as process IDs, network, file system, and users. Okay, inter-process communication and everything. These can be done by your namespaces. So now I'm talking. So here we are discussing about the containers, but previously what is going to happen? Whatever the applications that are running in your server, that can be segregated by your namespaces, and this namespaces will be providing the process IDs for each and every process that is running. For example, let me show you one thing. Uh, Let me go with ps-ef. So here you can see these many number of processes that are running. Here you can see PIDs are assigned for each and every process. So who is going to assign these process IDs? This is one of the processor that is running. This is the application that I am running. So this is the process ID. Who is going to do that? So that can be done by your namespaces. So it is clearly evident that namespaces, containers. Here we are talking about the containers. What is a container? Container is also a Docker process only. So containers see only their own process, unaware of the processes on the host or the containers. So these namespaces will allocate the process IDs. For example, if I run a container, okay, if I run a container, that container is also included as a process in your Linux operating system. So namespaces are very much helpful for you to provide the process IDs, file systems, users, and all the things. Okay, so this isolation, what happens when the namespaces isolate one of the process with another process? So each process operate independently and do not share the resources unless explicitly configured. So one application has to be dependent on the another application. Then only the resources will be shared. Until unless the resources will not be shared, one process will have its own application and the another process will have its own application. Just think in this fashion. For example, you are having a house in the gated community. Okay, you are having your own house inside the gated community. So you will do your own work and your neighbors will do their own work. They don't need to involve into your work and you don't need to involve into their work. So in the same fashion, in the Linux operating system also, whatever the applications that are running, or else whatever the processes that are running, each will have their own work to do. They don't need to involve into the another processes work. So this can be done by the namespaces. So this is one of the feature that help the IT industry to develop a concept called as containers. Okay. So do you have any questions with the namespaces? Any difficulties that you find in the explanation part? Any confusions, guys? Hello. Anything that you need to understand, or else do you find it okay with that, or else can I go for the next one?
Yeah.
Sorry, your voice is breaking out. Your voice is
Yes.
breaking.
I
Okay, no problem.
got it, your point.
Yeah, right. Fine.
Yes,
Thanks.
I got your point, Chaitanya.
Thanks, Suresh. Anyone wants to add on anything for this? Do you have any questions related to this? Related to the namespaces? We are not still into the Docker and containerization. We are just into making you understand what is a container. Okay, so first you understand what is a container, then we can create a container and we can run the application. Any questions here? All right. So yeah. So this is one of the section where we have understood about the namespaces. Now let us understand another feature that is called as C group. Okay, mute yourself. There is another concept called as C groups. So now what is this C groups? C groups means control groups. The name itself defines that these this feature inside a Linux operating system will do certain jobs. Suresh, mute yourself, please. Right. So now what is going to happen in the C groups, control groups? Now there is an application running. For example, in my Windows operating system, Chrome is running. So when the Chrome is running, it is going to run multiple tabs or multiple application inside this browser. For example, if I open another tab and I can go with any another application like in this format. So when I go with this, the point is what is going to happen for my resource consumption over here. Now, if you see, the Chrome is using somewhere like 1 GB, 1.4 GB of memory. Okay, if I open another tab, then it is going to use some amount of additional space or also additional amount of RAM will be consumed. So now if you can see here, 1.5 GB, it has moved to 1.5 GB. If I open another tab and go with the Terraform .io. So whenever I am increasing the number of tabs, obviously what is going to happen in the memory? The memory consumption is going to be increased. So which means that whatever the background processes that are running, one second, Terraform. Okay, which means that whenever we are running the application, so obviously the memory consumption and resource, CPU consumption is going to be increased. Now, who will monitor this and who will manage this? To do that, we are having a concept called as C groups. What is the C groups is going to do? C group will understand, okay, so the user required this much amount of memory, this much amount of RAM for this application. So I have to use only this much amount of memory and RAM. So that can be segregated and that can be done by your C groups. So that is called as control groups. Now, if you can see when containers are started in Docker, they run as a process in the Linux host. This is very important. I hope you understand this particular point. When containers are started in Docker, okay, they run as a process in the Linux host. But before we go into we are not at install the Docker and we are not at discussing about the Docker. If there are the processes that running in the Linux host, these processes requires resources. Every process, every application requires the resources. For example, the Google Chrome requires the resources. Resources are nothing but CPU and memory. And for example, your Word application requires the resources, CPU and memory. And your Paint application requires the resources. So each and every application, whatever in general, whatever you run in an operating system, they require the CPU and RAM to run the application. Now, who is going to help you with that? So that is what? By default, these resources are shared among all processes running in your Linux host, which can lead to the resource contention. So now what is going to happen whenever we are using the application, a particular application may consume lot amount of CPU, lot amount of RAM. Okay, so what is going to happen at the particular point of time when the load is applied onto your application, obviously that application will consume huge amount of resources, huge amount of CPU, huge amount of RAM. Simple. For example, you are going to a shop to purchase a mobile. Okay. So every day it is okay. Only 10 customers, 20 customers, or else maximum 100 customers are coming to that particular shop. Suddenly you have announced a bonanza offer in a shop of mobiles. Okay. You have announced a bonanza offer saying that we are providing iPhone 16 only for 40,000, 30,000, 30,000 to 40,000. Do you even imagine that particular cost? Obviously, we cannot imagine. That is an exclusive offer that we are providing only for a particular period of time. Now, just think about the crowd which is going to stand in front of that particular shop. What about the load? In general, the load is limited, but the resources will be limited. Inside that shop, only 4 sales executives, 1 manager will be there. Only total number of 5 people will be there. If suddenly if we announce a bonanza offer, exclusive offer, then what is going to happen? Whether these salespersons can be able to sustain that crowd? Do you understand my point over here? Is the salespersons are going to sustain for that crowd? Obviously not. Why? Because the crowd which is coming to that particular shop is way behind their expectations. So definitely they need to have more number of resources. But here what is happening? We don't have more number of resources. Now all the resources are going to be consumed by a single, are going to be consumed by a single application, and then the server will be going down. So this is the problem which we are going to face. So to overcome this problem, what we are going to do here is we are going to have the control groups. What this control group is going to do here is they are going to limit and allocate the resources for the processes. This process, we are going to provide only 1 GB of RAM and this much amount of processor. If the requirement, if the application is going beyond the 1 GB of RAM, then the application process will be terminated and new process will be restarted. So that is going to happen. So this is one of the feature that will be helpful for our containers to run. So previously, if you take these two examples, these two features, one is the namespace and the other one is the control groups. By combining these two into the IT world, the IT experts has introduced a concept called as containers. So what are these containers? Containers are nothing but a processes that are running with the help of, or else that are handling the applications and their dependencies. Again, I'm repeating the concept over here. Containers are the processes that are running in a Linux host, which can be handling the application and its dependencies. Okay, containers is not an, what I can say, it's not a fancy word to define. Okay, containers are not a fancy things to define. Containers are just the processes that are running in a Docker engine, Docker application. And these containers are the processes which will be handling the applications and its dependencies. Okay, so that is called as containers. Any questions here? Up to now, whatever we have discussed, any questions? Do you understand what is meant by a container, guys? Am I going over technical?
Yeah.
Yeah, thank you, Suresh. Any other person?
Yeah. Yeah.
Yeah. Guys, I want each and everyone's input, guys, over here. I don't want, I'm continuously getting the response from the Suresh. That's fantastic. But I want each and every person to be responding for this. Do you understand what is meant by containers? Do you have any questions related to that? What is meant by C group? What is meant by namespace? Am I going over technical? Anything?
Yeah, we are good. I'm good. Chaitanya.
As of now, I hope that everyone is fine with whatever the content that we have discussed. Any difficulties, guys, if you want to share that, you can ask me in between itself. Don't worry. Maybe I will tell that. Okay, I will tell you in the next session. But right now, it's not like we are going with the full phase itself. So if you have anything to ask me, you can ask me now. Right. So now let us discuss about the next concept. How to install the Docker in your Linux operating system. How we are going to install the Docker in our Linux operating system. I'm not going with very uh, different approach. Just simply I'm going to install Docker in a simple manner Later, I will show you how to install the Docker. Right. So simply what you have to do, curl -sl http :/ or else https://get.docker.com and bash. If you give this command, the Docker will be installed on your Linux operating system. So right now we don't have the Docker in your Linux operating system. Let us see that. I just shared you the URL. You can use that in your server. If you don't have the server, we will see in the next session. But as of now, let us see whether the Docker is available or not. So to check out that, what I will do, Docker info. So there you go. It is saying that there is no Docker, or else Docker PS. Docker is not available in the Linux operating system. So I'm going to install it. So just give me a second, guys. So, yep. Hold up.
Hey, does it require any prerequisites to before you go ahead to install? Like
No,
any minimum CPU, minimum RAM, something like that?
no, nothing. So I'm using a server of one CPU and 1 GB of RAM. Whatever
Okay.
you are seeing the server, it's 1 CPU and 1 GB. It is no, we don't require anything. If there is any requirement, I will let you know about that.
Okay.
Right. So we install the Docker. So here you can see Docker info. Look at that. So previously we got an error. Right now it's installed and it is running. So now what I want to explain you here, we are going to run an application. We are going to run an application in a container. Okay. For example, I want to run a web server. I want to run a web server. Okay. In my Docker engine. So right now what is happened over here, I am having a Linux operating system. Basically try to understand the architecture over here. This is the Linux operating system. This is the hardware which we are having. Okay. This is the hardware which is of 1 CPU and 1 GB RAM. That's it. 1 CPU and 1 GB RAM. Now what I did over here, on the top of this we are having an operating system. On the top of this we are having an operating system which is our Ubuntu operating system. Ubuntu, and for this we are having a concept called as kernel. On the top of that, what I did, I installed Docker engine. Right now we are having the Docker engine. Okay. So this is the Docker engine. Right. So now what is my requirement here is I want to run a web application or else web server. So now what I have to do, previously, if you see the virtual machine architecture, that is completely different. But right now, whatever we are discussing is completely different. Now, when we are discussing about the virtualization, okay, so previously, yesterday also somebody asked me, sir, what is the difference between virtualization and the containerization? Now, if you see here, in the virtualization also, you will have the hardware. You will have the hardware. Okay. So I'm talking to bare metal virtualization. There are two types of virtualizations. One is the bare metal virtualization and hosted virtualization, but I don't want to confuse you. Let us suppose there is a hardware which is of 16 CPU. There is a server which I purchased which is of 16 CPU and 512 GB of RAM. Okay, 512 GB of RAM. This is the expensive hardware. I'm talking only about the hardware. I'm not talking about any operating system. So there is no operating system. There is only the hardware, which is of your cabinet and monitor, CPU, RAM, and storage. These are available for that. Okay. On the top of that, what I'm going to do here is I'm going to install virtualization software. I'm going to install virtualization software, which is called as server side. It is called as VMware ESXi. VMware ESXi. And then there is one more concept, one more virtualization called as Citrix Gen or else Citrix, or else there is in Windows there is a concept called as Hyper-V, okay, hypervisor. So any virtualization software you can use. Directly I'm going to install on the hardware. Now what I'm going to do here is I'm going to install the server virtual machine, nothing but the logical. So this virtual machine is going to get the resources from the physical hardware. So this is VM1, which is going to get the resources. So this virtual machine requests two CPU and 8 GB of RAM to run the operating system and its applications. Okay, 2 CPU and 8 GB of RAM. So from where it is going to get this resources? So this virtual machine is going to request the resources from your physical hardware. From here only it is going to get the thing. Okay. So now on the top of this, I'm going to install the operating system. This is called as guest operating system, guys. Try to understand. Whatever the operating system we are installing on the virtual machine, that is called as guest operating system. Guest OS. It might be Ubuntu, Windows, Red Hat Linux, SUSE Linux, any operating system. For this instance, I'm going with the Ubuntu operating system. On the top of it, I am going to install an application. I am going to run a Java application. Okay, for that, what is the dependency? I need to have the Java installed on my virtual machine. So I will install the Java application. I mean Java runtime. On the top of that, I am going to install the application. On the top of it, I am going to install the application. Now this is app 1. Which app it is? It is a Java application. Try to understand one thing over here. Okay, so what is going to happen now? Whenever this application requires any resources, it is going to communicate with the guest operating system. For this guest operating system, there will be kernel, and this kernel will communicate with the hardware and provides the resources for this application. Okay, this is going to happen. Now, on the top of this particular virtualization, I can install one more virtual machine. Okay, one more virtual machine. This is VM2. VM2, which is of 4 CPU and somewhere like 16 GB of RAM. Okay, this virtual machine is having 4 CPU and 16 GB of RAM. From where it is going to get the resources? Obviously from the hardware. On the top of this virtual machine, I am going to create one more guest operating system. This time I will install the Windows operating system. Guest OS. This time it will be Windows. Okay. So on the top of this virtual machine, I am going to install a .NET related application. So the runtime will be .NET. Runtime will be .NET. Okay. So on the top of this, I am going to install an application, app2. Now, if this application requires any resources, app2, this application requires any resources, then what is going to happen? This application will communicate with the guest operating system, and the guest operating system will provide the resources from the virtual machine. So this is what in general going to happen. If you want to create one more virtual machine, you can create. So n number of virtual machines up to the hardware limit, you can create the virtual machine. There is no problem with that. Okay. So this is what the conventional virtualization will be looking like. But when you come back to this point over here, what is the point that we need to discuss here is, for example, I am having the Docker engine. On the top of the Docker engine, what I am going to do here is I am going to create a container. So what is meant by container? A container is a process that is running in your Linux host, okay, or else in your Docker engine. So this container is designed, C-A-I-N-E-R. This container is designed to run a Java application. So it needs to run the Java app. So for that, we don't need to install this guest operating system. There is no necessity for the entire environment to be set up. Okay, so entire guest operating system, kernel and everything. So, but here, if you see the virtual machines, in the virtual machines, we need to install the guest operating system where it should install the kernel and other dependency applications and all the things. So which will increase the weight of this virtual machine. So right now, I don't want that to be happen. So now what I will do, I will create a process which is called as a container. Inside the container, what I can do here is I can install the application. Either it might be a Java application or also web application or also a database application. It doesn't matter. So I'm going to simply install the application only. So now what I will do, I will create a container. How I can create the container? Let's see. Docker ps. When I give this command, it is going to, what is this Docker ps command? Docker ps command will show you the running containers. Right now, we don't have any sort of containers running in my Docker environment. So now what I have to do, I need to run a container. So how I will run the container? Simply Docker run -itd. Just remember the command over here, docker run -itd, name of the container is web and with the help of Ubuntu. So I'm taking the Ubuntu as an image. Try to understand now. So did you install any operating system on any server or else any laptop or else any desktop? Did you install a Ubuntu operating system or else any operating system? How much amount of size will be there for this Linux operating system in general? Do you understand my question over here? If you are installing, okay, if you are installing an operating system, what is the size of that particular operating system in general?
So
Yeah.
usually by CPU count and the memory size.
No. I'm not talking about that. See,
Okay.
if you are having the hardware, right? You are having
Okay.
the computer, CPU, monitor, keyboard, mouse. You purchase that. You are having a hard disk. Now
Mm-hmm.
you need to install the operating system, right?
Mm-hmm.
For that operating system, you will use certain devices, either it might be CD, DVD, or else pen drive. You are going to use to install that operating system, right? Now my question
Mm-hmm.
is, what is the size of that operating system which is present in your CD or else which is present in your pen drive? In general, what will be the size of Ubuntu operating system?
512 and 512 gigabyte or one.
No. You are talking about the hardware. You are talking about the storage. I am talking about Ubuntu ISO file. Normal
Okay.
Ubuntu file is, what is the size of the Ubuntu file? Okay, so if you see here, now see there, what is the size here? 5.9 GB. 5.9 GB is the size of your operating system, 24.02. Now, if you go with another type of operating system, it is 3.6 GB. Minimum, there is 1 GB of size, which means it is having all the features. If it is loaded with all the features, you are going to get the Ubuntu operating system of size 5 GB or else 3 GB. Minimum 1 GB of size is there for your operating system. Okay. But if you see here, what I'm doing, I'm creating a container. Okay. So when I create the container, what is the size of this image? What is the size of this image? So Docker images, if you give this command, see what is the size of this Ubuntu image? What is it?
8.2.
78 MB only. It's just 78 MB, which means that how it is reduced that much amount of size, because it doesn't have any sort of features. It doesn't have any sort of pre-requirements. It doesn't have any preloaded applications. It's just having the environment. It just have the environment to run the applications. So now a container is created. Here you can see Docker PS. Previously we don't have the containers, but right now we are having a container called as web. There is a container created with the Ubuntu image, and that container is called as web. Now I said, container is a process that is running in the Docker environment. Container is a process that is running inside the Docker environment, which will be running in your Linux host. So to understand that, what I will do, ps-ef, if you look out this, look at there. There is a container, or else there is a namespace called as Mobi, where it is running a container environment. Here you can see a Docker-D container is running. I mean, Docker-D process is running. So which means that, let me show you that particular container over here. ps-ef grep container. Yeah, look at that. This is the container process. Previously, we don't have that container process. Now let me go with PS, or also, sorry, Docker PS. What is the container ID? B23B. Okay, this is the container ID. If you can see, there you go. B23B. So here you can see the container ID is available, which means that whatever the container that is running in your Docker engine, it's a process running in your Linux operating system. Am I clear with this? For example, if I kill this container, whatever the container that I have created, if I kill the container, docker rm-f web, I'm going to kill or else remove the container. Docker ps, I don't have any container running, or else if I go with docker ps-a, there is no container running. So if I go with the same command again, ps-ef grep container, look at there. Previously, we used to have this process in my Linux operating system, but now I don't have that process. So eventually, what did you understand from this? Whatever the explanation that I have given, a container is a process running in the Docker engine inside a Linux host. It's just a process. Inside the container, we can run the application and its dependencies. Am I clear with this explanation? Any questions over here?
But why there are some more processors showing up, right? 2467 and 2621. What is those process?
These
Those
are
are
the
Docker
processes
process
that are helpful for running your Docker application.
or Docker application. Okay.
Okay. Any questions? Right. So now what I will do here, I will create one more Docker container. Okay. So Docker run -itd -name, web is the container name, and with the help of Ubuntu image. Okay, now the container is created. Docker ps, and if you can see backend, a process will be created. Look at that, D3 E89. So what is the container ID? D3 E89. Okay, so a process is created. Now what I said you over here. So I said you that what I'm trying to explain you. So a container is a process in the Linux host, and inside the container we can install the applications whatever we want. So now let me log on to that container. Docker execute -it. What is the container name? Web. And if you give bash is the command. So docker execute -it web. Up to here it is common, guys. Okay, the command is common, but it is going to differ with the operating system, with the whatever the image that we are using. If we are using Ubuntu, we can go with the bash. If you are using a Red Hat image, then you can go with the bash. But if you are using Alpine Linux, which is a very, very small Linux, you can go with the sh command. So there is a difference. If whatever the flavor of Linux you are using, the shell will be changed. It is very simple, guys. What I am trying to explain you here is, for example, if you want to access your Linux operating system, you need to have a shell. So just forget about this terminal. This is called as a terminal. Two things you need to remember in Linux. One is terminal. Terminal in the sense with the help of whatever the application you are trying to access your Linux operating system, that is called as a terminal. Okay, here I am using putty as my terminal to access my server. Or else in some cases you can access Mobi Extreme as a terminal to access the Linux operating system. But I'm not talking about terminal. I'm talking about the shell. Shell is an interface which will be helpful for you to interact with your operating system. It's a terminal which will be helpful for the user to access the server. Try to remember it. To access the server, we are using the terminal. But to access and interact with the operating system, we are using a concept called as shell. Okay. Shell is like an interpreter. Okay. Just like in our Windows, we are having the graphical user interface. In the same manner, for Linux, it is called as a shell. So different operating system, different flavors of Linux will be having different types of shell. For Ubuntu and Red Hat and CentOS, to say these are all will be going with the bash. There is a operating system called as Alpine. So Alpine Linux will be going with the SH, or else Unix operating systems will be going with the SH. SH means shell. Bash means burn again shell. KSH is there, CSH is there. Like that, you are having multiple types of shells are available. But majorly, we are going to use bash as one of the shell and SH as the another type of shell for different operating system. Right now, we are using the Ubuntu environment, so I am going with the bash. But if you are using an operating system or else you are using an image to create a container and that image is Alpine Linux, then you have to go with the command called as sh. Am I clear what has to use when? Do you have any confusion over here? If you have anything, just let me know about that.
So
Any
can we create a Windows containers too? Only Linux on Ubuntu?
we can create, but that is also we can go with the shell itself. Okay, but that's a different, right? So let me go inside the container. So how we are going inside the container now? If we can see, look at the terminal over here, root at the rate IP address 10.100.185. This is the name of the server. But when I press enter over here, look at now what is happened. Root at the rate D3E89. What is this D3E89? It's a container, which means that right now I am inside the container. Am I clear here?
Yeah. And one more thing, everything is created with the root, right? Do we need root is mandatory for this?
No. We can go with the normal users. That's a security privacy issue if we go with the root. But anyways, I will explain you about that. Okay.
Okay.
Right. So next, what I'm going to do here is, next what I can do, I can install my application, whatever the application that I want. So how I can install? So for Ubuntu operating system, we are having a package manager that is called as apt. For Linux, Red Hat Linux or also CentOS, we are having a package manager to install the application called as yum. Like that. And for Alpine Linux, there is a package manager called as APK. What is this package manager going to do? It is going to search the repositories in the internet and install that repositories in our Linux operating system. Now what I will do, right now we don't have any package installed. Now if you see what is the size of the Ubuntu image, it's just 78 MB. So which means that if I go with the ping is the command which will try to communicate with whatever the given IP address. So ping google.com. So it is saying that ping utility is not available. Okay, what is the IP address of this container? For the container also you are going to get the IP address. We will discuss about this in the Docker networking, but just we are inside the initial setup. Just understand this. If config utility is also not there, and if you go with any utilities, it is not available. So now what I will do here is I will install the utilities inside my container. apt install -y, or else first of all let me update the repos. apt update -y and apt install -y iputils -ping net-tools, which means that I don't have that if config utility is not there to check out the IP address of the container. So I am installing net-tools. Net-tools will install the if config utility. IP utils ping in the sense ping utility is not there, so I will install the ping also. And if you want, you can install any another utility also. Right now, basically these two are my requirement, so I will install them. Once it is installed, now if you see if config, what is the IP address of this container? It is having 172.17.0.2. That is the IP address of the container. What is this IP? How we are getting the IP addresses? Everything I will explain you in the Docker networking concept. But please be patient. Okay. Please keep your patience. Definitely you will get to know about Docker networking, Docker architecture, everything. But initially we are inside the container. I said you that container is a process which will be helpful for you to run the applications. So now what I will do here is I will install one more application called as Nginx. apt install -y Nginx. Okay. So what is this Nginx? Nginx is a reverse proxy and a web server. Don't get confused about what is meant by proxy. You don't need to understand about that. It's a web server. Okay, that's more than enough. Now I install the Nginx. Okay, so I will come out of the container. To come out of the container, what you can do here is press Control P Q. Control button, P and Q button. If you press that, you will be coming out of the container. Previously, you can see this is the container ID. Right now you are inside the server. Okay. Now what you have to do here is Docker PS. I am having this web container. Now what I will do, I will convert this container into an image. Docker images. Right now, if you see, I am having only Ubuntu image. Whatever the container that I am having, Docker PS, this is the web container which I am having. Now inside the container, I have loaded with my utilities. I loaded with ping utility. I loaded the container with the what I can say net-tools utility. I loaded the container with the Nginx utility, which means that the required utilities are loaded inside the container. Okay. Just for example, let me tell you, you are having a system, you are having a computer. So inside the computer, you loaded all the applications, whatever the required applications are there, you loaded all of them. Now you purchased a new computer. After 2 years, what you have done, you purchased a new laptop. For example, you purchased a new laptop, but your requirement is that you need to load all the application into that laptop. So what you are going to do? Are you able to understand my question? You have a old computer in your home where you have loaded with all the application required softwares. If you are a travel blogger, you install the Canva, you install whatever the video editing software, you install everything. Just the example I'm telling. So you install all the applications and it is running good and your system is pretty fine. But it is not portable. So now what you have done after 2 years, you purchased a laptop. Now you need to have all those applications installed inside your laptop. So you need to purchase the laptop, you need to install the operating system, and then you have to install all the application one after the other. So it is going to take lots amount of time to install all the applications. Despite of that, what you can do? It's very simple, guys. You can convert that desktop, whatever the computer that you are having, you can create a system image and you can copy that system image from your desktop to the laptop. Just for example, if I am having all the applications loaded inside my uh, what I can say Windows operating system, let me show you one thing. Control. I will go to the control panel. So inside the control panel, what I can do here is I can create a system image. There is this backup and storage. Yeah. Here you can see create a system image. What it is going to do here is whatever the applications, whatever the data that is present in my Windows operating system, that entire data and applications are going to be converted as a single image. And that image I can connect it into my new laptop and I can transfer all the applications. I can install that system image on my laptop so that I am going to get all the applications, data and everything. So in the same manner, what I can do over here is whatever the container that is present in my Docker, okay, whatever the container that is present in my Docker, I can convert this container into an image. Okay, so how I can do that? So Docker one second. Docker commit, okay, Docker commit, whatever the container. So the image name is Nginx version 1. This is the image name with the help of the web container. I want to create an image with the name Nginx version 1 with the help of the web container. If you don't provide this tag, just you are providing Docker commit Nginx and web. So Nginx is the image name and web is the container name. So now what is going to happen? One second. Web and Nginx. Look at that. So I have an Nginx image created. There you go. Nginx latest image, which is of size 135 MB. Previously, your Ubuntu image is having 78.1 MB. Now, if you see here, there is an image which is created. It is having 135 MB. Why there is a sudden change in the size of the image? What happened? Why it is showing 138 MB? Because inside the Ubuntu container, whatever the container that we have created, we install the utilities called as net tools, we install ping utility, and then we install the nginx. Due to which the size of the image has been increased from 78 MB to 135 MB. So which means that I converted this web container into an image format. So inside this Nginx image, we are having all the applications whichever we install inside this web container. So now what I will do, I can create one more container with this image. Okay, with the Nginx image. Now what I will do, docker run -itd -name. The name of the container is test container and with the image Nginx. There you go. Docker ps. Here we are having web container and then we are having the test container. Let me log on to the test container. Docker execute -it test container and bash. So now I am inside the test container. If you can see ping is available. If config is also available, and nginx systemctl status nginx. Okay, or else what I can do, you can start the nginx is also available. So the point what you need to understand here, you can be able to install all the applications. Okay, inside the container you are having all the applications running, and whatever the utilities are preloaded into this images are available inside the container. So what is an image? We will discuss about that. But as of now, we have created a container. So now if you can see Docker PS, the processes that are running are the test container and web container. Now what I can do, ps-ef grep container. So I just want to show you what are the processes that are running in my Linux operating system. Here you can see there is a namespace called as Mobi. A Mobi namespace is created inside which we are having the two containers running and which are into the isolated environment. One container one container is not having anything to do with the another container. So this is called as your processes, containers, and how we can run the containers inside your Docker engine. Any questions, guys?
And each container there is own IP address, right?
For every container, you will have its own IP address.
Okay.
I know today it will be overwhelming for you. It will be more technical who are attending to the new session. But as I already said you in the first session, that from day one itself, we are starting into the Docker and Kubernetes. I don't want to repeat again and again to make you bored about everything. Every day you will have a new topic. Okay? Yeah, go on. Suresh, your voice is breaking.
Hello.
Hello.
Yeah, yeah. I have some network issues. Now, hello. I'm visible. Sorry, audible.
Yeah, you are audible.
Chaitanya, I'm audible. Yeah, I have some doubts.
Mhm. Tell me.
Yeah, how to create a container?
How to create a container. Just now I have showed you how to create the container. Docker run command.
Okay, Docker run command.
I have
Please,
shown you. I have
how to
shown you.
install?
Hmm. Go on, go on.
Yeah, Docker software. How to run the code and how to run commands.
I showed you curl-sl get.docker.com and bash. It will install the Docker. I gave you the command in the chat box also.
Okay. Thank you, Chaitanya.
Yes. Anything else?
Oh no, no.
Right. Uh, guys, any questions?
And one more thing, Chaitanya, where it will be stored in the directory, all these things?
Very
In
good
which
question.
directory? Yeah.
So the Docker will have its home directory where var lib docker. So here you can see you are having the containers, images, overlay networks, runtime, swarms, volumes, everything will be available over here. Okay.
Okay. The containers which contain the containers.
Yeah.
Okay. So this is only the directory. Everything is Docker is here. Or
Yeah,
do you have
Docker
any?
related everything will be by default, it will be in the warlib Docker. But if you want to change the home directory in the companies, they won't ask you to create in the default directories. This is the default directory, warlib Docker. But when you are inside
Okay.
in a company, they will ask you in a different location. I will show you how to create, how to change the home directory of Docker from one location to the another location.
Mm-hmm.
Okay, right.
Thank you.
Anything else, guys?
Sir, actually, this Linux operating system we need to use only this.
You can use Windows also.
Okay.
So in Windows, we are having a tool called as Docker Desktop. If you are interested to run with the Linux, you can run with the Linux. No, sir, I want to run in a Windows operating system. Yes, you can run in the Windows operating system with the help of Docker Desktop. You need to install. So simply go to Google and check Docker Desktop installation. Install Docker Desktop on Windows. Simply download this. Okay, x86-64 guys. So all our Windows operating system will be running on x86-64 architecture, not the ARM. ARM is for the Mac operating systems, ARM processor. Okay, but right now we are having AMD and Intel. Simply download the application and install the application. That's it. Okay.
And then it is Windows. We no need to that commands. We no need to write that
No, no, no.
commands.
If you want, you can run with the commands, or also if you can go with the GUI also. For example, I want to create a container. Okay, so here you can see there are multiple containers that are running. Okay, so now what is my requirement over here? I want to run the container. Simply go to the command line. Same commands, whatever I have used in the Linux, you can use the same commands. Docker run -itd hyphen name web container with the help of Ubuntu image. Okay, it is going to run that particular container. That's it.
In real time, means most of the companies which operating system uses like
In
Linux.
most of the if you want to have the graphical user interface, you want to understand it more efficiently, you can use the Docker desktop. But the companies will not use in the Windows operating system. They will be going only with the Linux operating system.
Oh, okay.
Okay, my suggestion is that see, if you want to run in the Linux operating system, commands will be the same. But the point is, more effectively, I want to go with the production environment. I want to learn in what happens with the company environment. So then try to do practice with the Linux itself. So then it will be very, very helpful for you to understand the commands and multiple times you will run the command so that it will be habituated for you. Okay. Shell will be very habituated for you rather than the graphical user interface.
Okay, sir. Thank you.
Right.
And Chaitanya, So how can we access through console also this Docker?
Console, in the sense, you are asking about the web console.
Yeah, web console. Yeah.
Right now, it is not necessary. We have a Docker Swarm visualizer. I will show you that, but it is not like we need to access that from a console. We can use the commands itself.
Oh, commands. Okay, there is no user interface
No.
for the Docker itself.
If you want the user interface, you can go with the Docker desktop itself. Docker desktop is a user interface, right?
Okay.
But that is for the Windows.
Oh, not for Linux.
Not for, especially if you want to install the Docker, if you are having the Linux UI, you can install the Docker onto that also. But my recommendation is that UI we won't use in any Linux operating system. In any companies, we will be going with the commands itself. So I recommend you just go with the command. Right.
Okay. Thank you.
Yes. Any questions, guys? I'm expecting the questions. Is everything is okay? Can I wrap up the session here? Anything that you want to ask me? I don't see any questions. That's it from my end. I hope I made it very clear for you. Anything you have, you can ask me in the next session also. So next session will be the final demo for you. So, and then whoever has been enrolled for the session, they will be attending to the sessions. And yeah, whenever DurgaSoft has called you, please respond to the call. If at all, if you are not available, just ping, put a message to them so that at least they will know about whether you are interested or not. That's it from my end. So today I think so many people. So our DurgaSoft has called to each and every person, but I don't know whether you have picked up the call or not. But I got a feedback that some people didn't pick it up. At least you pick up and say if you are interested, I'm interested to join. If you are not interested, we will check out after the demos, or else you are not interested straight away, so that it will be completely understandable for us, so that I can take a feedback and I can I will try to improve myself. Okay, so it's not like this is my, I think, 30th batch, I think, Docker and Kubernetes. It's overall 30 batches I have completed in DurgaSoft itself. Okay, so which means that over that period, I trained somewhere like 1,500 to 2,000 people on Docker and Kubernetes itself. So my request is that if you have anything to do, so just say that if you are interested, just say interested or not. That's it. Okay. So yeah, I hope I'm very much clear about that. Have a nice day, and we'll meet in the next session. Bye bye.